Hi everybody, we are in chapter 5 and we finally reached the end of chapter 5, which is section 5.6. We're going to be talking about linear inequalities, and specifically we're going to be talking about graphing inequalities in two variables. So this is going to look a lot like graphing y in y equals mx plus b form, graphing linear equations, but we have a bit of a twist and we'll talk about that. Let's take a look at some vocabulary. And it looks like it's extensive, but it's not too bad. Our vocabulary words are, the first one's boundary. It's when an equation splits the coordinate plane into two spaces in a way. So if I were to have a coordinate plane, we remember it's just the xy axis and all the space that's included here, right? So if I were to have the coordinate plane and I were to draw, let's say, a graph of a line like this, if this line extends forever and ever, I've literally split my coordinate plane into two spaces, and I can call one space this yellow side and then the other space this blue side, right? So this line would be a boundary, and I've split it into two half planes, which gives us the next definition. So boundary would be a line, half plane would be what happens when we draw a graph and we cut the coordinate plane into two spaces. A closed half plane. Now sometimes when we do some problems, we're going to see that we want to include half of the plane as our answer. It'll make sense a little bit later, but we may not want to include the line. So in a sense, in a situation like that, you will see, let me see if I can get white here. So you will see, never mind, you'll see a dotted line that says that the line is not included, as opposed to a silent line when the line is included. So I know that seems a little bit strange, but I think it'll make better sense when we do a couple of examples. So just to close, a closed plane is when the line is included. That means a solid line. A half open plane is when the line is not included, and you'll have a dotted line when you're referring to your graph. All right, so this is just a little heads up. It'll make sense when we look at some examples. Let's get started. So here we're going to graph this inequality. 3x minus y is less than 2, and what we're going to do is we're actually going to treat this kind of like a linear equation. If I had to graph this, I would prefer to put this linear equation into y equals mx plus b form, or slope-intercept form. To do that, I'm going to do exactly what I would do if this were an equation, except I'm going to follow the rules of dealing with an inequality. So the first thing I need to do is get y by herself. So I have negative y is less than negative 3x plus 2. Notice what I did. I subtracted 3x from both sides of my inequality. Cool, right? Now this negative y is not what I'm trying to solve for. I'm trying to solve for a positive y. So in a sense, I'm going to have to divide both sides by -1 or multiply both sides by -1. When I do that, the signs of everything will change, but also the direction of this sign will change, right? You remember when we multiply or divide both sides of an inequality by a negative, the orientation of that sign flips, and we've talked about that a lot in the earlier sections. So we get y is greater than 3x minus 2. Notice that all the signs changed. So what I do is I'd actually graph this line, but first I need to indicate something. Y is not equal to 3x minus 2. Y is definitely greater than. So there's a couple things that need to happen here. Two things that are really important. First, this line that I'm going to draw has to be dotted. And so when I draw this, I'm going to go to -2 over here. Let me see. I'm going to go to -2, and I go up 3 over 1, up 3 over 1. You know, just utilizing my slope and my y-intercept in order to draw this line, but this line will be dotted, okay? Because y does not equal this, y is being compared to this line, and it is deemed greater, okay? So y must be greater. So there's two ways to do this next piece, and that's to determine which half plane is going to satisfy this inequality. See, this line doesn't answer this question. Half of the plane is going to have to answer this question, meaning there's going to be points x, y that are going to satisfy this, that are going to be either on this side or this side of this boundary line. And what we need to do is figure out how to figure that out, right? The way, there's two ways to do it. One is to say, well, y is greater than all of these points here, 3x minus 2. Y being greater than means that it is above. That is a legitimate way to do this, which makes sense, right? So I can therefore come and shade everything here, and my solution is indicated by what I have here. The way that is recommended by your textbook, which makes sense as well, is that you choose a point. You see that this is we have two half planes here. So this is a section and this is a section. We know that the answer is going to be in one of these sections, right? So either the answer is this side or this side. The way to test is to pick a test point. 0, 0 is a very good test point. And if 0, 0 satisfies this inequality, then we know that this side is the answer. If 0, 0 does not satisfy this inequality, then we know that the opposite side is the answer. So I've already answered this by analyzing what I see as the inequality y is greater than this, but let's use the technique of choosing a point. So my chosen point, I'm going to call that 0, 0, or the origin. So I'm testing to see if this side works. I plug 0, 0 in. 0 is 0 greater than 3 times 0 minus 2. Is 0 greater than ultimately negative 2? Yes, it is. So that tells me that the side containing the origin is actually the side that is our solution. All right, I know that was a little talkative and a little confusing. Let's see if it'll make sense as we look at another example. So here's another one. We're going to graph this inequality. Similar to the last one, we're going to treat it like an equation, like we're used to. So that means solving for y might be pretty helpful. Another way of actually graphing, to be quite honest, that I think we don't utilize enough is using the intercept points. Because really, if we know that this is a line and we're going to graph a line, we need 2 points. What better 2 points than if we can find the x and y intercept? And this problem, as I look at it, really lends itself to that. So I'm going to actually do this a little bit differently. I'm not going to solve for y and do the whole slope thing. I'm going to actually use our x and y intercepts. So the x-intercept and the y-intercept of the line, well, this isn't exactly a line. I should call it the related line. So the x and y-intercepts of x plus 5y equaling to 10, because that's what we're thinking about. The x-intercept means I'm going to put a 0 in for y, and so I get x plus 5 times 0 is equal to 10. So sorry for that sloppiness. So then I get x is equal to 10, right? Because if I plug a 0 in here, I get that. So my x-intercept is 10. When I throw a 0 in for x and calculate my y-intercept, looking at this line, I get that y is equal to 2. So y equals 2, x equals 10, 1, 2, 3, 4, 5, 6, 7. Okay, I'm going to have to count by twos. So let's call this 2, 4, 6, 8, 10, 12. And let me just be consistent and count by twos on the y-axis. I don't have to, I just need to be consistent along the x-axis, but just to give us a better view, I'm going to be consistent on the y-axis as well. So this is a 2 here, and this is a 4. And so I need the 2 as my y-intercept and the 10 as my x-intercept. And this line is going to be different. The related line that I'm using is going to be included in the half plane, all right? And the reason why it will be, sorry, that dot was just ridiculous. The reason why it's going to be included is because x plus 5y is less than or equal to 10. So that equal to says that it is a part of the line. So now, and I can see what this is going to be. Forgive my sloppiness. I'm trying my best, people. That's not too bad. So that's the line that I'm working with, and that's going to be a part of my solution because, again, it is equal to. Now the question is, we need to choose a test point. My test point is going to be the origin because it's easy. If the origin satisfies, if 0, 0 satisfies this inequality, I'm good to go. I'm going to choose that side. If this is not included, if it does not satisfy this inequality, then the answer is obviously the other side. So let's check it out. My test point, I think last time I called it my chosen point. I meant to say test point. My test point is 0, 0. So 0 plus 5 times 0. Is that less than or equal to 10? 0 plus 0 less than or equal to 10. Is it? Of course 0 is less than or equal to 10. And so what I'm going to do is shade down here. So this side has been included. Because the origin is included, this half of the plane is included. So my solution is this line and this half of the plane. Remember, if the origin did not work, it just happened to work in the last two. If it did not satisfy, then we'd be shading the other side. All right, let's go ahead and take a look at example 3. In example 3, we're going to solve inequalities from a graph. And so in this case, this looks a little peculiar, right? I've got 3x plus 5 is less than 14. Where's my y? Well, when I don't have a y, I'm going to solve for x. So I have 3x plus 5 is less than 14. If I subtract 5 from both sides, I'm going to get 3x is less than 9, x is less than 3. So this is my equation. Well, this is my inequality. The related equation would be x is equal to 3. This is an equation that you guys must detest because I just keep getting it. Just people hate things that are undefined in terms of a slope. But this is the undefined slope, friends, right? This is my undefined slope, and this is going to give me a vertical line at x is equal to 3. But wait, x is not equal to 3. In fact, x is less than 3, so I'm going to have to rock a dotted line here, right? Have no fear. I'm going to just make that a dotted line like that, okay? So I've got my dotted line. Now I need to figure out which way to shade. And I can do the same thing that I usually do. I can choose the origin. The origin is 0, 0. When I put it, but there's no y, you're saying. That's okay. Just put a 0 in for x. When I put a 0 in for x, what do I get? I get that 3 times 0 plus 5. Is that less than 14? It is. So I'm going to be choosing this side. You probably already noticed that it says that x is less than 3, so we'd be choosing this side anyway, and that's also another fine way of doing this problem. So I'm shading all on the left side because that satisfies my inequality. All right, let's see what else we have going on. Example 4. In example 4, we're going to write and solve an inequality. We've got a couple of facts that we need to attend to here. The first thing is that a yearbook company will give the junior class a picnic if they raise, sorry about that, I'm still using white, let me undo that. If they raise a certain amount of money, and the amount of money is $28,000, and they can do it in 2 ways, with a combination of the purchasing class rings, which costs $140 a piece, or the yearbooks, which are $35 a piece. So these are the 2 big things that we're thinking about. We're going to consider X, the yearbooks, and Y, the number of rings. So this is the number of yearbooks sold, and this would be the number of class rings. And if the 11th grade, or the 11th grade, if the junior class is able to sell enough that the sum is over 28,000, they'll get this class picnic. So what we need to do is to illustrate this as a graph. Okay, so we recognize that X deals with yearbooks, and I've taken the liberty of having along the X-axis yearbooks up to 1,000 yearbooks, and I wrote over here our class rings. I know that doesn't look great, but up to about 500. And what we're going to do is we're going to graph the line that is represented here. And I did that by finding the X and Y intercepts. The X and Y intercepts, this means that I can sell 200 rings and we'd make the minimum of 28,000, or I could sell 800 yearbooks and make the minimum. So this line is considered in our answer, and then I would be shading everything above that. And how do I know that? I can choose a point above that and realizing since that point above, this line splits our plane in half, since the point above is included, then I know that the whole thing is included. What point did I choose? I could choose any point. I know usually we do the origin, and you could do the origin. In fact, we could do the origin. Let's do the origin again. So sorry about that. If I chose the origin, I would put a 0 here and a 0 here. And I get 35 times 0 plus 140 times 0. Is that greater than 28,000? No. So I do not shade this portion, and the other half of the plane works. So what that means is any ordered pair located anywhere around here represents a point or a value of rings and yearbooks that could be sold that would guarantee that junior class their picnic. All right, I hope that this made sense. I look forward to talking to you guys soon. This is not the easiest subject, but don't worry about it. I think you guys have the skills to handle it. Feel free to ask me any questions, and know that I cannot wait to see you tomorrow. Have a good one. Bye-bye.